All right, everyone, let's go ahead and get started. Okay, number one. So you may have done this or you may not, but it's okay. Just fast forward to where you need. Dazzle in distress is being held captive in a tower. Her knight in shining armor is on the ground with a ladder. All right, so not much information except tower and a ladder. The knight stands 15 feet from the base of the tower and looks up at his precious damsel. The angle of elevation to her window is 60 degrees. How long does the ladder have to be? Right, so I have the ground. Okay. I have a tower here. Right. So this is where she's at. And I like to spend a little extra time doing this, And let's say she's up here. Right? So this is her window. And she is up here. And we'll make her a blondie. Right? Hey, that's Smurfette. Blue and yellow hair. Blonde hair. Right, that's Smurfette. Anyways, all right, so there's a knight down here. All right, and he has a ladder going up there. So his ladder something like this. Okay, let me double check. I get the information. Blah 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 blah. Knight stands 15 feet from the base of the tower, and the angle of elevation to her window is 60 degrees. How long does the ladder have to be? All right, so we want to find out this ladder here. How long is it? Right, if he wants that angle of elevation 60 degrees, and he is. See, I missed that part. 15 feet from her window, from the ground. Right, so he is 15 feet from the base of the tower. So he is 15 feet. Okay, so that's a scenario. We don't care about how tall the tower is, right? We just want to know, what, how long the ladder is. Right, so this is going to utilize, let's see, SOHCAHTOA. Right, we have the adjacent side, and we have the hypotenuse. So adjacent and hypotenuse, we are talking about cosine. Right, so we're going to be using that. So here we go. Cosine 60 degrees equals adjacent, which is 15, over hypotenuse, which we don't know, and we're going to just call it the question marks. Okay. I'm going to do what we sort of did in class. I'm going to go ahead and multiply both sides by 1/15 to get rid of that 15 from the top. So by 1/15, I just basically am dividing it by 15. Right, so that's going to cancel. And I will have 1 over question marks. That's going to equal cosine 60 degrees over 15. Right, now we can use a unit circle to find cosine of 60, but you know what? Since we have the calculator, why not? Right? But this doesn't help us solve because we still want just the question marks, right? We still want the length of the ladder, not 1 over that. So if we flip, right? If we reciprocal both sides, right? The top and bottom, that means we have to do it to this side also. So top and bottom is switched. So now we finally have question marks, right? The length of the ladder is equal to 15 on top and cosine 60 on the bottom. So in your calculator, you would type in 15 divided by cosine 60. Make sure you are in, see, I'm in radian mode, and check out what happens, right? I get some weird, funky number, negative 15.4 as my question mark, right? That's definitely wrong because that ladder cannot be negative 15 feet long. But as soon as I change it from radian to degree mode, right, and I type in the same thing again, I get 30. Right, so that ladder is going to be 30 feet. Right, so he needs a 30-foot ladder. Right. So number one, how long does the ladder have to be? 30 feet long. Okay. Number two, you are 20 yards from a river. Rather than walk directly to the river, you walk 400 yards along the straight path to the river's edge. Find the acute angle between the path and the river's edge. Okay, this problem sounds very familiar. Right? It does sound very familiar. So, I got a river. You're right here. It says what? 200 yards. And instead of walking directly to the river, you walk along a path to the river's edge. That's 400 yards. So you are going to be moving along there. So you, and I'm doing this for people who were not there for our in-class exam. You're going to walk along here, 400 yards, to the river's edge, right? And the question is, what's the angle at the river's edge and the path? Right, so this right here, we have a 90-degree angle here. Forgot to mention it to the last one, but you probably figure out where the 90-degree angle is for that damsel in distress problem. In this problem, we're looking at opposite from the angle over the hypotenuse. So opposite over hypotenuse, we're looking at opposite. We're looking at sine, opposite hypotenuse. See, opposite hypotenuse. So we're going to use sine of theta, which we don't know, is equal to opposite, which is 200, over the hypotenuse, which is 400. Right, this one's really straightforward because all we have to do is get rid of the sine because the theta is exactly where it needs to be. So in order for that to work, we need to multiply both sides of the equation by sine inverse, or not we need to multiply. We need to inverse sine. That's how you say it. Both sides of the equation. So inverse sine of sine theta equals inverse sine of 200 over 400. And yes, you can reduce 200 and 400, but I'm lazy, so I'm just going to leave it alone. Okay. When you inverse sine a sine, you will be left with the angle. And then now in the calculator, you need to figure out what inverse sine of 200 divided by 400. And please close that parentheses, right? It will work without it, but please close it for just for completion, right? By doing it, because every now and then you may have other things, and if you don't close it, you will get a wrong answer. So theta equals 30. 30 what? 30 degrees. Wow, 30 so far. So 30 feet long, and the acute angle between the path and the river's edge is 30 degrees. Okay. A 12-meter flagpole casts a 9-meter shadow. Find the angle elevation to the sun. Right, so again, it's the ground. Get a flagpole. Actually, let's make our own flagpole. Right, it's going to cast a shadow on the ground. Right, so 12-meter flagpole casts a 9 9-meter shadow. Okay, I know I'm a little bit off, but hey, you know what? Sue me. Right? 12 meters casts a 9-meter shadow. Okay, and obviously the sun is about right here. That way, when the sun shines, the light comes from the sun, it hits this, it actually ends up right there. See that? And when you're looking up towards the sun, this is your angle of elevation. So with this right here, we have an opposite side and adjacent side. So opposite over adjacent. So that would be tangent, opposite and adjacent. So we're going to use tangent of theta equals opposite is 12, adjacent is 9. Right? And again, to find out, you just got to do the inverse tangent. So tangent inverse of both sides. So tangent inverse of tangent theta equals tangent inverse of 12 divided by 9. And yes, you can reduce 12 by 9. But again, I'm kind of lazy tonight. Getting close to my bedtime. So I'm going to go ahead and leave it to the calculator. So I'm just going to type in tangent inverse of 12 divided by 9. Okay, so it's a 53.13 or 53.1 or 53 degree angle. So I'm going to go with 53.1. Just keep it pretty simple. So theta equals 53.1 degrees. Right? If I had reduced 12 and 9, excuse me, 12 divided by 3 makes 4, and 9 divided by 3 makes 3, I will get the same exact answer. You see it? 53.130, and all the numbers match. So I would say the angle is 53.1 degrees. Okay. Suppose you fly a kite and it gets caught in the tree. You let out all 100 feet of string for the kite. The angle that the string makes with the ground is 75 degrees. Instead of worrying about how to get the kite back, you wonder, how tall is that tree? Okay, you know, 100 feet and 75 degrees. Okay, I think I have an idea. And if you do, do it. Pause it. Don't let me ruin it for you. We have the ground. We have a tree. Okay, just do what you can. Okay, I'm not the best artist, but I do enjoy a little just messing around. Okay, you are on the ground. You let out 100 feet of stream. Your kite, let's make this a red kite. Your kite is stuck in the tree now. Okay, so you let out 100 feet of string. That's how it's stuck. And then the angle that it makes with the ground, that angle is, let me go back and check, 75 degrees. Right? And then instead of getting the kite from the tree, you ask yourself, how tall is that tree, or at least where I'm stuck at, right? So you want to find out how tall is this. Okay. Actually, you know what? I don't like question marks anymore. Let's call it X, okay, or Y. We'll call it X, right? So what do we have? We have the angle and we have the opposite from the angle. So opposite right here. And we have the hypotenuse because tree supposedly grows straight up. So that means 90 degrees right there. Right, or at least 90 degrees right here. Right. So it's the same thing. Right. So we have opposite. Oops. Oh, I did not know you can do that. Pretty cool. I didn't know that I can draw in and then still do the redo. Pretty cool. Maybe this is just a fluke. Anywho, um, so yep, that's a 90-degree angle right there. Okay, because it's the same 90-degree angle with the tree. Because the tree supposedly is going to grow straight up. So we have opposite and hypotenuse. What are we using? Opposite, hypotenuse, we're using the sine. So sine 75 degrees equals opposite, which is x, hypotenuse, which is 100. Right, this one's pretty easy. Multiply both sides by 100. The 100s cancel, and we get x equals 100 times sine of 75. So I'm just going to use a calculator. That gets me 96.59 or 96.5 or 96.6. We'll go 96.6. Right, so 96.6. All right, and that's feet. Not sure where he does that, but 96.6 feet tall. Okay, number 5. I know we did this in class, but we'll do it again just in case somebody missed it. Okay. Suppose Mike and Dave are making measurements for the road paving crew. They need to know how much the land slopes downward from a particular stretch of road. Right, so we got a sloping land. Right, so it doesn't matter if you start from the left or right hand side. I'm going to go ahead and say I'm starting from the left hand side. So the land is sloping downwards, kind of like that. Okay, and you got two guys. You got Mike and you got Dave. All right, so Mike and Dave. Dave walks 80 feet from Mike and holds up a long pole perpendicular to the ground. So Dave goes do 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 do. So he walks 80 feet from Mike and he holds a pole which is perpendicular to the road because he doesn't know anybody who's on the road. So that's a pole right there. Maybe too tall for him, but you know, that's a pole. Okay. Mike looks at the pole through a sighting instrument, looking straight across, parallel to the horizon. So you know, I mean, when you think about the horizon, right? You know, like a beautiful image or in a painting, the horizon is, you know, it's what is the landscaping in the back, and the horizon is something that's horizontal, like perfectly horizontal. Right, so that's a horizon. So Mike is gonna look through, and it's gonna be parallel to the horizon. And you know what? For Mike, that's actually he's like right there, right? So, and because we don't know how tall he is, or it doesn't say anything, we're just gonna assume that he's right on the road, or his height is negligible, and he's gonna look straight across, parallel to the sorry, parallel to the horizon. So the blue line. So it's gonna be the same direction. So like that. And then he sights it on the pole. Okay, maybe that pole's too big. And he sights that it's 50 inches above the ground. Yeah, maybe that pole's too big. Right? He sights that, hey, you know what? At point A, that's 50 inches. Here, I'll put down. Okay. I'm calling point A. Then Mike looks through the instrument at the bottom of the pole, creating an angle of depression, which is the angle of depression or slope of the road where Mike is standing. Right. So when it says slope of the road, it has to be on the road itself, like this. That's why I'm making Mike on the road itself. So when he looks down, because he is the road, we are looking for the angle of depression. How much does he have to actually look downward? So we're looking for this angle. Okay. And one more information, we need to know that Dave walks 80 feet. So from here to where Dave is, that's 80 feet. Okay. So pretty much straightforward. We have with the angle, we have the side opposite the angle, right? The side opposite it. And we have the side adjacent to the angle. So we really need just to use opposite and adjacent, which is the tangent. Okay, erase the horizon, right? But before we do that, you might notice that your units for the opposite and unit for the adjacent are different. So you need to convert either the inches to feet or the feet to inches, and it seems easier if you convert the feet to inches, right? Because 80 feet and every feet has 12 inches, so it'd be 80 times 12. Okay, and 80 feet times 12 inches, right? Or 80 of the 12 inches is 8 times 12 is 96, and then with a zero. Or, in case you don't trust yourself, like me right now, and don't want to look like a fool, 80 times 12, 960. All right. So instead of 80 feet, we're like, yeah, let's scratch that. Instead of 80 feet, let's call it 960 inches. I think that's much easier. Okay. So again, we're using tangent, right? So we're using TOA, which is tangent of theta, which we don't know, is equal to opposite, which is 50 over 960. Right, and in order to solve this, we need to inverse tangent both sides. So inverse tangent of tangent theta equals inverse tangent of 50 over 960. Right. So those inverse tangents and the tangent will cancel, leaving you with just nice fat theta. That's what you want. And the inverse tangent on your calculator of 50 divided by 960. And yes, you can reduce. A little lazy right now, so I'm just going to let the calculator do the work for me, and you will get 2.98 degrees or 2.9 degrees or approximately 3 degrees. Right, so theta is about, and I'm going to stick with 2.9 degrees. Right. If you use the 8 and you round the 9 up, then you get 3 degrees. So it's up to you. I'm going to stick with 2.9 degrees. All right, so the angle of elevation, I don't know why he does that, but what is it? Sorry, the angle of depression is 2.9 degrees. Okay. Number 6. And if you've already seen it, fast forward. Right? That's what fast forward is for. Okay. Submersible traveling at a depth of 250 feet. So you got the water, ocean, 256, or sorry, 250 feet down. So 250 feet down, there's a submersible. Okay. I know it looks like a plane without wings, but right. There's a submersible, 250 feet down, and then it dives at an angle of 15 degrees with respect to the line parallel to the water surface. So water surface, water is always flat. So it's going to dive parallel to this line right there. Okay. And it dives at 15 feet, and it travels a horizontal distance of 1,500 feet. So it travels 1,500 feet, and then it dives kind of like this. The angle that it dives at is 15 feet, or 15 degrees. Right. So it travels, and then so by the time it finishes diving, right. So it basically does this. It goes, ooh. So right. So what it does is it goes diagonally 15 degrees down. So that's what happens. Okay. So it's actually, at the end of the day, it's actually down that much more deeper, right? So from this angle, 15 degrees, we are looking for the opposite, and we have the adjacent. Right? So opposite and adjacent, we are talking about opposite, adjacent, got the TOA, right? Opposite and adjacent. So opposite, adjacent. So that means we're talking about the tangent, right? So we got tangent, 15 degrees equals the opposite, which is x, the adjacent, which is 1,500. Pretty easy with this one, because all you got to do is multiply both sides by 1,500. These will cancel, and multiply both sides by 1,000, and this side by 1,500. So you will get x equals 1,500 times, or you don't have to put times, but I'm going to leave it, tangent of 15 degrees. That's going to get you 401.9. Okay. So that means that your x right there is 401.9 feet. Okay. And let's think about this, right? So 401.9 is the answer, but it's only this far down. This is 401.9 feet. Okay. But you were originally 205 feet. And then now you went down 401.9. So you need to add them together. Okay, so you need to add them together. So you get a total of, use a calculator if you need to, 401.9 plus 250, 651.9. So what's the depth of the submersible after the dive? It is 651.9 feet. Okay, if you want to round it a little bit more, you can say it's approximately 652. You want to keep it with nice numbers. All right. Number 7. Fire department's longest ladder is 110 feet long. All right, that's all I know right now. Longest ladder that the fire department can use, 110 feet long. Okay. Safety regulation states that they can use it for rescues up to 100 feet off the ground. So let's say a burning building. Yep. Okay. That doesn't look right, but who cares? Right. Burning building. 100 feet only. Here. Okay, that's their regulation. What is the maximum safe angle of elevation for the ladder rescue? Right. So basically, they're asking, what is this angle down here that is safe? Right. Because maybe we don't have 110 feet long, right? But we still want to know the safe angle, so we got to use that. Okay. So we have the opposite from the angle, so opposite, and we have the hypotenuse because 90 degree is at the house. All right, so opposite and hypotenuse is opposite. Hypotenuse, we're talking about sine. So we'll go sine theta equals opposite, which is 100 divided by hypotenuse, 110. Right. This one is we're going to require us to use an inverse sine. So we will inverse sine both side. Inverse sine of sine theta. Inverse sine of 100 over 110. Right, these will cancel, leave us with the theta, which is the angle of elevation. Right, elevation means how much do we have to lift up or look up. So on the calculator, inverse sine 100 divided by 110. Excuse me. And that's 65.38 or 65.4. Right, so our angle, elevation angle is 65.4 degrees. That means this one. We can lift it up 65.4 degrees. Okay, and the last one. Hopefully this wasn't too long. I'm having fun doing this. I don't know about you guys, but you know what they say, besides the very hard times, which used to be at the, when I first started teaching, besides those very difficult days, the saying is, if you enjoy what you do, you never have to work a day in your life. And, honestly, I mean, for all you guys, I mean, I do enjoy what I'm doing, and I don't really feel like I've been working. Okay, not a day. Well, actually, maybe just waking up in the morning. I mean, I do enjoy sleeping in a little bit more, but I mean, besides waking up early, because I am coming in from Madera all the way to Fowler, which is about slow drivers, about an hour, fast drivers, maybe about 45 minutes. Um, yeah, I mean, I feel like that's work. But other than that, once I'm there, I don't feel like I'm actually working. So, okay, last one. Brothers Bob and Tom Katz buy a tent that has a center pole of 6.25 feet high. Okay, so that's a center pole. Ugh, that's an ugly center pole. Okay, don't buy this tent. So tent. It's a tent. Right, and we know it's perfectly symmetrical because it has as if the sides of the tent are supposed to make 50-degree angle with the ground, right? If the sides, right, here's the word sides. So that means that here's the ground, right? They're putting 10 out. These are going to make 50 degrees. Okay, so we're actually looking at one side of it only. We're looking at one triangle. Okay, this triangle here. Okay, we don't work with the whole thing. We only work with half, and then we can apply it to the rest. And we want to know how wide is a tent. So yeah, at the end of the day, we want to know how wide is it from there to there. Okay, but once you find out how high or how wide, we need to figure out how wide half of it is. Again, we're looking at just half the tent. So we're looking at it from here to here to here. Okay, a little better looking, but okay. So what do we have? We have the opposite side. So here's the side. It's opposite of the 50 degrees. And we have and we need the adjacent. So we need to use opposite and adjacent. Okay, so opposite and adjacent. We're talking about tangent here. So tangent 50 degrees equals opposite, which is 6.25, over the adjacent, which is x. Yeah, I like that. Okay. I'm going to go ahead and this one's kind of like one of our earlier ones that we've done. I'm going to go ahead and multiply both sides by 1 over 6.25. 1 over, and this side right here, 1 over 6.25 really means it's just division by 6.25. Okay, these will cancel, and you would get your 1 over x on the bottom. Right, this side will be tangent 50 over 6.25. Okay, you're going to go ahead and reciprocal both sides because we don't want 1 over x, we want just x. So that means we're going to reciprocal the left-hand side as well. So we will finally get x equals 6.25 over tangent 50 degrees. Okay, so what is x equal to, right? Well, that's for your calculator to figure out. So we have 6.25 divided by tangent of 50 degrees, and we get a total of 5.244. So I'm going to go ahead with 5.2. So x is equal to 5.2 feet. And if this side is 5.2 feet, the other side is also 5.2 feet. This side is also 5.2 feet. So total is going to be 10.4 feet. So total is going to be 10.4 feet. Okay? Because we need both sides of it. All right. So that's a wrap there, everyone. I know this might take a little longer than you have expected, and I'm posting it a little late in the evening. My apologies. Sheesh. Right, but final answer. How wide is the tent? The tent is 10.4 feet wide. All right. Okay. We'll call it a wrap.